Every single AI response you generate starts as a massive physical operation inside thousands of miles of heavy industrial machinery. The cloud is actually a network of warehouse-sized data centers, packed with millions of physical computers. Running this complex software requires a massive footprint of hardware and energy that dwarfs the requirements of previous digital tools. Training a single AI model requires thousands of specialized GPUs, running at full capacity for weeks or months at a time. This graph compares the static energy output of traditional city power grids against the sudden exponential spike in global AI power demand. Traditional tech hubs depend on fossil fuel-heavy grids that simply cannot generate enough electricity to keep pace with these new requirements. These dense clusters of processors consume immense power and generate enough heat to damage the hardware. To keep them running, data centers must spend even more electricity on industrial-scale air conditioning. The industry is hitting an infrastructural wall. To continue expanding, AI companies need a location that provides both unlimited power and an environment that cools the machinery naturally. Because AI is a resource-intensive physical process, the next stage of its development is being dictated by geography rather than code. That search has led companies to a geological anomaly. Iceland has a population smaller than many mid-sized cities, yet it is becoming the primary bedrock for the global AI industry. This deep tectonic fissure shows why. Iceland sits directly on the mid-Atlantic ridge, where the North American and Eurasian plates are pulling apart. This separation allows magma to rise near the surface, heating massive underground reservoirs of water into high-pressure steam. Engineers capture that steam to drive turbines, generating electricity 24 hours a day. By combining this geothermal energy with hydroelectric power from glacial rivers, Iceland maintains a fully renewable and stable power grid. This immense power supply solves the compute bottleneck. AI facilities here have access to gigawatts of clean electricity, allowing them to operate with a near-zero carbon footprint. While the heat below provides power, the freezing temperatures above ground solve the thermal problem. Instead of using electricity to run cooling units, these data centers pull in the freezing outside air to naturally regulate the temperature of the server racks. Using nature as a cooling system dramatically lowers operational costs and increases the overall efficiency of the hardware. To bridge the distance between this remote island and the rest of the world, data travels through fiber optic cables laid across the floor of the Atlantic Ocean. These connections provide low latency and high-speed access to global markets. Furthermore, operating within the European Economic Area ensures the data is handled under strict digital sovereignty protections. Iceland has become a specialized environment for AI infrastructure, utilizing the Earth's fire for power, its ice for cooling, and the ocean for secure transmission. The growth of AI is no longer just a matter of logic and algorithms. It is now a matter of geology and physical power. Major technology companies are investing billions to build GPU clusters here, using protective engineering to manage the risks of the active volcanic landscape. The irony of modern technology is that constructing digital intelligence relies on harnessing the planet's oldest and most violent physical forces. The next time you ask a chatbot a question or generate an image, remember that the answer was physically powered by a volcano.